Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even
Hey folks, we're back again. I'm Martin, Making Data Simple. I am here with Tina Tarquinio, and she is the Chief Product Officer for IBM Z, LinuxONE. She's a MHV, Senior Location Executive. What's MHV?
The Mid-Hudson Valley, in my mind, one of the most beautiful places in the world.
See, I set you up. Yeah. So Tina, thank you for joining me today. Hey, I've been wanting to do this. We're going to talk about the mainframe, I think, today. Everything I just said, Z, LinuxONE. But before I jump in, please introduce yourself, talk about a little bit of your history, and then I'll jump in with some questions.
Awesome. So thank you so much for having me. I'm a longtime listener, so I'm thrilled to be on the pod. So I've been at IBM a little over 25 years. I am an MHV local, so I am born and raised New Yorker and raising my family here in the Mid-Hudson Valley. I started at IBM as coming out of college as a math and computer science double major, and I joined IBM writing microcode for power systems. And then I did a whole bunch of things, and eventually I landed in product management, and I was the product manager for the IBM Z14 ZR1. And product management felt like home. I loved being at the intersection of our clients, our technology, making the roadmap. It just felt like home. And so I really haven't strayed since. Since 2020, I've been in a few versions of this role, last year becoming the Chief Product Officer. And, I'm someone that, every time I get a new job, I think I have the best job yet. And I think it speaks to a lot of the way IBM works and what I bring to the role. But I think I have one of the best jobs at IBM, and I'm really lucky to get to do what I do every day.
Say more on that. Why do you think you have the best job? Curious.
Well, part of it is what I get to work on. I get to work on this incredible technology with these brilliant people, and our clients who are spectacular. They're running every financial transaction in the world, and at the back of all that is a mainframe, right? And so working on the technology that makes that better, doing it differently, more efficiently, effectively, the engineer in me just thinks that's the coolest thing. And then, working with our clients every day, equally great and brilliant. So it just feels, just a joy, and, that I'm really lucky to do what I get to do. I come to work excited every day. So to me, that feels like I hit the jackpot.
Fantastic. We should have done this face-to-face. I'm in Armonk today. So yeah. We could have found a way to do that, right? Have you, just to be clear, have you always been in product management? Have you always been in mainframe?
Nope. In my product management roles, yes. I would say the first half of my career, I was in power systems. I worked around storage for a little bit. I had, kind of a pure systems role, some DSAK roles. And then when I first came to the mainframe, I was on the engineering test floor. So kind of the last quality assurance runs, 5 to 6 months pre-GA. And then when I came to product management, I've always been around Z, either on the hardware or software side. When you launch a new IBM mainframe, it's kind of like a IBM-wide event. And so you really get to see the full breadth of what happens when IBM comes together. And I think that added to the fun and great experience of product management in Z.
Now, I'm going to jump in here, and I do want you to get technical at some point, but I'll just start off very simply. What do you think is the most surprising thing you've learned about the mainframes since you've been a part of them?
There's all sorts of gee whiz, holy cow, there's, 24 miles of wire on a processor. The way we, there's all sorts of interesting things about the way we build them for ultimate resiliency and supreme scale. I think one of the most surprising things is when you start to talk to your clients and you see how they take your technology and turn it into a use case, and you're always that's pretty cool, or sort of how we intended for it, but you guys took it another level. So that's always sort of the cool moments, when you're learning about the mainframe. The mainframes have been around for over 60 years. I have not. So, when you start to learn about some of the forethinking that, engineers prior did and how that's playing out, it's just really cool. I think the other thing that people may not realize is the community of mainframers at IBM and outside IBM is just spectacular. It's so cool. Every time we go to a tech exchange or a Think or pick a conference, right? The mainframers, they're just so passionate about what they do. So I think that's sort of something people may not realize, exists in the strength it does.
Yeah, Tom McPherson on one point in time was talking about IBM Power, and he was talking about how the user group, this user group literally has tattoos of Power on them. That's kind of like the mainframe group, if you will.
Yeah, they're really more into pins than the tattoos, but they they astound me with their enthusiasm, and it makes you want to build the best thing you can. But their knowledge and the way they just think to use the technology. I mean, it's such an incredible platform that it's just great to see it kind of out there. For people that don't interact with it every day, just sharing, 90% of the world's credit card transactions run through the mainframe. It really helps drive home to those maybe not in it every day, like how important the system is just to sort of like the world's financial engine.
What did you say about the wire? By the way, I missed that. 20.
So on a Z17 processor, there's over 24 miles of wire on a single processor, which is kind of like an inch by inch little square, right? And it's just there's all sorts of gee whiz things. It's there's billions of transistors in the systems, and our engineers figure out how to not only fit it on there but make it do the things we want it to do.
Have you ever wanted to or ventured into engineering, or product management is still your sweet spot?
So I started in engineering. I think it would be hard to be a good product manager without understanding the engineering side. I think engineering for me, product management for me, it's where engineering intersects with our clients and our go-to-market. And to me, I like that, intersection and helping make all three pillars work. So I feel like I get to be a part of engineering when I'm designing the roadmap and we're figuring out what stays in or what stays out of a roadmap. But I don't have to solve all of the putting all these people on everything problems. I get to work on the product level problems. So, but the engineers, they're doing, engineering just on the tools that they work with and, making themselves more productive as well. So it's always cool to hear the stuff they're working on.
How do I want to start this? Let me start it this way. And I'm not necessarily going to go easy on you because I'm going to ask it this way. Look, the interesting thing about the mainframe, like you say, it's like 95% of all of Fortune 100s. I mean, you can give me the right data points there. Almost every ATM, nearly 100% ATMs. I mean, the whole financial industry is built on it. I think over time, what happens is it's such a core piece of technology that every competitor would like to take out. It becomes the long pole in the tent. So it gets labeled legacy. So the modernization is to take your mainframe out or something like that. Look, I was acquired many years ago now. And look, I didn't know much about a mainframe, but if you read what you read or whatever, there's a lot of that out there. And you're like, then you get here and I got here, right? And it's not because I'm an IBMer. I hope I've earned the right to be totally honest. It is freaking amazing what this thing can do. Yeah. It would be like calling, I don't know, a Tesla, even though a car has been around longer than a mainframe, 100 years, by saying, that's a legacy. We never call a car, that's a legacy car.
Right. We compare ourselves to Porsche. We would never say a Porsche's legacy. Certainly it has a history and a legacy of, innovation. And I think of it that way. And, Alex Go will tell we don't say legacy, we say legendary. And, that's sort of our twist on it. But we talk a lot about fit for purpose. What are the SLAs? What are the latency requirements, the security requirements, the availability, scalability requirements? And there are some workloads that cannot be served by any other platform but the mainframe in terms of scale. When you think about a market open, all right, you have maybe 10 seconds of extreme scale where you can't afford any interruption, any latency, any downtime. Think of Black Friday in the US, there's days like that around the world. Where you need the extreme scale and the security, think about a post-quantum error. So we talk about fit for purpose. There are some things that can run in multiple places. What's their affinity to the workloads? And I think when we go down the fit for purpose discussion route, you really start to narrow in on the strengths of each platform, the needs of each applications, and you make the right decisions. In terms of efficiency, our consolidation ratios for Linux are 16:1 we benchmark, but we see much higher than that, out in practice. And, just building for, the financial world, but also, new workloads are springing up around AI that also can't have any, impacts to service and the same level of security. So that's really where we guide the discussion around fit for purpose when those discussions do come up.
Well, can you talk a little bit about really characterize the mainframe around like reliability, availability, scalability, transactional processing, give folks out there, what the latest mainframe is capable of. To your point, when I'm meeting with clients, look, it used to be, honestly, like about 5 years ago, there was a lot of talk of like modernizing, taking out your mainframe. Almost every one of those, and I'm not stretching the truth here, that we looked at, you'd start and then they'd end up investing more in the mainframe I mean, I'm going to give you almost, but most of the time it was like the best opportunity that we had for the mainframe was to have that discussion. Now I don't hardly get any of those discussions anymore. And in fact, I think last year we had our best year of all time mainframe.
So
I mean, people say it's all garbage. I say that without any hesitation. I mean, it's like we had our best year.
Yeah, you could say it. We've had really outstanding performance, starting with Z14 really, but I would say Z16 generation, and we launched Z17 earlier this year, record-breaking quarters. So the strengths of the platform are serving our clients. At the core is sort of our unique shared, architecture, right? What allows us to have, infinite scale, near infinite scale with no impact to performance. I mean, that's the type of scale, high throughput IO we have. We have 8 nines of availability. So that's basically less than 0.03 seconds a year of downtime. So, and that type of RAS is built in at every layer of the system, at the hardware layer, firmware layer, operating system. So we have engineered the system to have, zero downtime, which, fun fact, the Z stands for zero downtime. So that is, at the core. And so when we do have these discussions and you talk about shifting workloads, well, your compute requirements go up, right? We have an incredible consolidation, play on the platform. The way you can, we did virtualization long before it was, it was hip and cool. We have some people that say, Z was the original cloud, right? In terms of provisioning LPARs and having, independent, workloads run. And our security characteristics, right? We have something called secure execution built on our hardware security module that is quantum safe now, basically allows workloads to run and not even, root access can understand what's going on. We make the joke about Coke and Pepsi, running in an LPAR side by side and, you can't steal each other's formulas. So we have this type of security that underpins the scale, which just makes it very unique, right? I mean, x86 servers aren't built for that. Cloud providers aren't baking in that kind of scale and resiliency. And if they are, you have a dedicated instance. And so your costs are probably out of control in that sense as well. So it really comes down to, what does your workload require? And then, let's get you the right tech. But the mainframe is really, it's been on a great run. So we're really proud of that. And that's on the strength of the technology, right? We introduced AI on chip, quantum safe encryption. We just are about to GA our first, PCIe attached AI accelerator. So we're really pushing the envelope forward. And just to give a shout out to my engineering team, when we introduce those things like AI acceleration on the chip, we're making our own chip. So it takes 5 to 6 years. So that means we thought of AI on chip 5 to 6 years before we introduced it in Z16. So the people we're working with and our clients are looking that far into the future and then building what we need. It's pretty cool.
To that point, again, I think you guys are always out in front. I was just meeting with a client, was it last week? Maybe the week before. The client actually was a state, and the state is worried about quantum breaking encryption. And we're talking about all the things you can do to prevent that or to get out in front of it because, the bad actors today are still in data waiting for the encryption to be broken so then they can then take your data, right? And they want to get out in front of that. And I went right into your Z boxes that you have today have encryption built in that is quantum safe. And now I'm sure that the IT organization, was well versed that they had that. But I was talking to some of the lawmakers and they're like, what? But again, way out in front. In fact, if I have this right, I think there were 4 algorithms that NIST took and 3 of them we invented, we as an IBM.
Yeah.
And the other one was invented by somebody else that I think, I haven't proven this or I haven't validated this. So just to be clear, that we brought that person on. So now we have all 4.
Of the algorithms that NIST is standardized on, so NIST is the governing body for this space in the U.S., 3 of the 4 algorithms had direct IBM involvement through our teams, obviously working with research, in our labs around the world. And the 4th, we had a tie to the person, as you say, that did the development. We actually have a distinguished engineer on the Z team that has now been asked to be part of one of the NIST boards. So I think that's really powerful that we are truly at the leading edge. And we're at the leading edge of the other side of it, right? Like if you look at IBM's quantum roadmap, we're pushing the boundaries there. So there's no better team to really understand what quantum computing can do than IBM, and then for us to build the quantum safe algorithms to make sure that they really do that. So to me, it's a really powerful story. Also brings together, I think, all of IBM from our research to our specific brand teams. I think is really, really powerful. And when we talk to clients, we share that. We're like, hey, we were a part of making all of this, and we know how hard it's going to be. So let's get started.
you talked to several leading edge technologies that are already part of the mainframe. Can you say more on AI on chip? I mean, how does that differ, or how's that different? How do I want to say this? How is that differentiated in the market versus anything like NVIDIA would provide?
Yeah, so in 2022 on Z16, we introduced the Telum processor, and it had on-chip AI acceleration. So that was in early 22. If you think about what was going on in 22, ChatGPT and everything was really starting to take off. So we had a lot of great foresight there. And we brought that into play because we were talking to our clients who wanted to do more in-transaction AI. And so latency requirements were not being met when they had to send an inference, so a fraud detection, a scoring action on a transaction. So you and I tap and pay, buy something, there's fraud detection in there. Sending it off platform was taking too long. So we needed to put it on the chip, on the bus, the same processor that was doing the actual financial transaction to do the fraud detection as well. And so that's what we introduced, and it allowed our clients to basically score every transaction and not impact their performance, which was, they were either choosing not to score or they were accepting, longer times to score the transaction, which as a consumer, we don't enjoy, but we also don't want the score to come back wrong, right? So we want better fraud detection. With Z17, we introduced the second generation of that on-chip AIU. We introduced a way for all of these on-chip accelerators to talk to each other within a processor drawer. So now there's 8 in a drawer that can talk and offload work to each other. And we introduced the IBM Spyre accelerator. So this is a PCIe attached AI accelerator for inferencing. It's purpose-built, so it's not meant to be a GPU like NVIDIA is introducing or their roadmap. So it's purpose-built for these enterprise use cases that require extreme scale, resiliency, and security. And that's where you can start to bring in generative AI, so large language models, and combine that with your more traditional machine learning, predictive learning. So there's an example I usually talk about, like say you're a homeowner, tree falls on your property, you go in, to your portal and you want to write up a claim. So the insurance company takes all this prose that we've written in about the car and it's the tree and it fell in my car, all these words. And the insurance company can take that in and use a large language model to look at the prose, assess it for maybe accuracy, sentiment. Do we think it's, fraudulent? And then pair that with standard data in a table. And then maybe they can approve your claim automatically and not need to, route it to a human. Or maybe it's a little bit more complicated and they do route it to a human, but they can be more productive. So these examples where you want to have predictive AI and generative AI work on the same problem needs different compute underneath. And so that's what Spyre brings to the table.
Would you say it's comparative to a GPU then? You mentioned that earlier that it kind of wasn't, but I mean, tell me more, Ida.
Yeah, it's not meant for the same types of workloads. It's really looking at these high throughput enterprise level transactions and those types of use cases. So, it's not your everyday average GPU or working on those use cases. When we introduced Z17 and the Spyre accelerator, we also introduced a suite of software, Watson X Assistant for Z. And this is where now we're going to start to introduce more agents in terms of, we can have the assistant that can help, with, data that's specific to the machine. And then you can take an action specific to the machine. And this can help with, maybe growing skills or just automating things that might be more rote and, don't need specific human attention all the time.
How do you see mainframes fitting into the hybrid cloud world we live in today?
Well, I will say, you were talking about 4 or 5 years ago, the modernization story. I would say 4 or 5 years ago, we heard a lot of what's cloud? I need to get to cloud. Can we move? Can I buy the cloud? How do we, I need to cloud. And we have spent a lot of energy making sure that the mainframe can sort of superpower your hybrid cloud and not be outside of it. So, exposing the data in various data sets, connecting through APIs. We have OpenShift everywhere. You can run OpenShift on LinuxONE, ZOS, and ZCX. You can run OpenShift, kind of being like a day one support for all of the Red Hat products. So that's really been our strategy, and it's really working, right? Everybody has a hybrid cloud. That's the state of things. And so making sure that you're not introducing security risks, duplicating data or business actions. And that's really where we've seen the mainframe kind of add to the hybrid cloud in a collaborative way across the enterprise.
What's your 2-minute pitch on LinuxONE?
LinuxONE is extreme scale and compute without compromising on sustainability, security, resiliency. So if your new workloads are really starting on Linux, and so if you need that extreme scale, but you do not want to compromise. That was really how we launched Linux 1.5 was, without compromise. So you can have the sustainability, meet all the power requirements you need, but you can still have the scalability and the security. If you think about a lot of fintech startups, right, they're trying to enter this massive ecosystem of financial applications, right? You want to talk about payments, digital assets. All that requires like extreme security. And that's really what Linux One can bring to the table as these startups are getting going.
Any other exciting innovations around the mainframes happening right now that I guess many people may not know about? Can you give us like something for the future that you're not supposed to tell us? You do that.
Ooh. I will say AI is going to be here to stay. So I talked about the Spyre accelerator. We're already working on Spyre 1.5, 2.0. We're already working through how we can keep this going. We're really a full stack platform, right? So IBM owns from chip to ship, right? We actually build the processors, we have the operating system, the middleware, some applications. So we're very unique in that when we introduce something on the chip and we can work with our software friends and say, hey, take advantage of this accelerator down on the core, that's a really unique advantage. And we spend probably what I usually call like an inordinate amount of time doing user research through design thinking at IBM. So really understanding our clients, not just the technology, how do you want to deploy it? So I think you'll see some exciting developments in terms of more hybrid cloud, being more integrated with Red Hat than ever before. The watsonx portfolio having full support on that. And then just as IBM starts to embrace different model strategies, supporting all of that on the platform, which is not trivial, right? If you go from IBM's models around Granite, and then you look at, external models, the sizes are changing daily, the requirements. So building all the technology that can handle that is kind of like a really cool engineering problem. I think the other thing you'll see is some form factors. So starting in Z15, actually Z14, ZR1, we came down to a standard frame, right? So we're no longer this huge two frame system. We fit on a single floor tile. And now we're expanding into, I think you'll see us expand into more form factors. So in Z16, we introduced a client rack system, which means you could basically get a mainframe with IO and compute in as little as like 18U in a data center, which is really kind of wild. And then in Z17 and beyond, you'll see us introduce even more options in like the racking and stacking, which I think for the Linux world will really have an impact. Quantum, we're going to continue to think about our quantum algorithms. How do we have like basically algorithm agility as new algorithms or derivatives? How do we stay current there?
What about DevOps and or automation in the framework of, you often get a lot of people saying, well, it's hard to find mainframe programmers or something like that. What's your answer to that?
I have a couple answers. The first is we have done a lot of work at the application level for application developers to have the same tools in a DevOps pipeline. So, GitHub, all of these things now really, really work same in mainframe as they do in, other environments. So we've done a lot of work there. We are now putting that kind of laser focus on the sysprog level, so the system administrator level, to make things work same, have similar language, call things the same when, trying to like lower that bar. And the last thing I would say is the amount of energy we put into our ecosystem group, which is led by my amazing peer Meredith Stoll, on creating these mainframe communities, making sure that as we bring on new talent through universities and other pathways, that we're setting them up with the right education in terms of skills. I mean, we have heard skills as a challenge. So there's work we're doing internally to make that, make our products have a lower bar, and then work externally to kind of bring up the skills in the community as well. And that kind of goes back to what I was saying in the beginning about like the mainframers around the world. They're just, these great people that want to help out and, keep it going.
Anything about the software that sits on top of it or have been derived from the mainframe, like Watson Code Assistant for Z? In some sense, like code assistants can be a commodity or becoming commodity, but the Watson Code Assistant for Z, whether it's Ansible or whether it's, or in this case, COBOL, sorry. I mean, man, it's completely differentiated and quite amazing because it's built on the mainframe.
Yeah, so I would say in that case, it's very differentiated. I mean, go back to the fit for purpose comments. I mean, COBOL is highly performant machine code. If your application needs that performance, what you really want is better, healthier COBOL. You want commented COBOL, COBOL with documentation. You want somebody to be able to go in and make updates to the COBOL instead of being afraid to touch it, but you don't want to change the performance of the COBOL. So watsonx Code Assistant for Z can get you really healthy, well-positioned COBOL. And COBOL is a mainframe thing. I mean, who better to introduce, a code assistant on COBOL than us, right? So I would say we're really differentiated there. We launched Code Assistant for Z last year. And, starting, with some of our on-prem accelerators, we're going to be able to run that on-prem. We've seen really great adoption, and I would say the biggest adoption we've seen within the suite of what Code Assistant for Z can do is in this explainability phase of the Code Assistant for Z. And that's where you go in and you really get comments in your COBOL, you get documentation, you understand what's calling what. So a newer person or somebody who didn't write the program 40 years ago can go in and understand what's happening and, again, make changes if needed. So that is where we've seen a real uptick in adoption. So I think that's pretty cool. The other thing that I think is really great is that even though things like Kix and IMS seem like they've just been around forever, under the covers, a great amount of innovation to take advantage of both the hardware, new hardware we're providing, but also to connect through things like OpenShift, other ISV products, what I think is really a kudos to that team in terms of, how they're trying to push the envelope forward on, things like Kix and IMS and DB2. DB2, for example, when DB2 announced DB2 version 13 the day after we announced Z16, they introduced a NoSQL database, which basically would help you create a model, in a very, very short amount of time, days versus months. And of course, when you ran the model on Z, it would take advantage of the accelerator we had on chip. So that's the kind of cool stuff I think our software team is really, really working on, up the stack.
Do you think on the AI piece, what's the most prevalent use case that you're seeing that you're working with customers on as it relates to the mainframe?
So that's definitely changed. When we first launched the AI at scale, we were a lot around fraud detection, and various types of fraud detection, but basically in transaction fraud detection. That changed over the course, I would say, of the last 18 months, and it sort of forked into two buckets. One is how can I use it for AI ops or better efficiency of running my environment, for sure? How can I use AI to, make better provisioning or workload management? So that's one growth area. And the other has been an expansion of the types of beyond the fraud detection and financial transactions. We are looking at loan approvals. We're looking at, cargo registries and making sure what you say is on the ship is on the ship. So the expansion of use cases has really branched out. We have medical images. We have a client that's using geospatial images and comparing it to the tax record. So if you've maybe improved upon your property, but you haven't let the town know, and maybe you're supposed to have a different tax bill. So we've seen some really, really cool use cases, life insurance policy approvals, loan approvals, some really kind of neat things like that that are just a little bit beyond the fraud detection where we started, which is that's all of our clients need to do fraud detection, right? As a consumer, I want them to. So that's always going to have like a big bucket of the use cases. But these others are pretty cool. Retail, what's a really cool one is like credit card reward program scamming. So there's, looking
a lot
at
in the financial space, it sounds like.
Yeah, for sure.
Pivoting to product management, what would you say makes product management for mainframes different from product management for, say, SaaS, mobile apps, or anything like that?
A couple of things. One, a lot of our clients already have the offering. So we have to, we're not in a startup mode where we're introducing them to what it is. We're more talking to them about what's coming, what's new, why they want to get what's new. Their use cases are, for the most part, pretty established. So you're either trying to improve them or work through new use cases. And they all, it's really a part of their heritage and their enterprise. So talking them through how to take such a critical piece of their infrastructure and move forward. So that's, I think, what makes it a little bit different than introducing a new SaaS offering. We're making a physical server with a lot of physical parts. So, you get into supply chain and, all those kind of things, the lead time. So it takes about 5 to 6 years to make a processor. So if I start a processor now for a system in 2031, my ability to change it in 2028 based on the market's probably limited. So, trying to sort of future-proof some hardware decisions you're making now. I would also say what differentiates us is we have an incredible group of clients that are like never turn us down to ask them, what are they thinking? What do they need? What's a pain point? What if we did this? Like they spend all the time in the world with us. And I know from my peers at other companies, they don't have that luxury, really a privilege. So that's some of the things I think set it apart. in a good way.
So you got several in there that I want to dissect, and actually had some questions I was thinking about. One was like, how long is a product roadmap for your products that you represent?
So we
And you're
introduced.
talking about 5 years where a chip. I mean, man.
Yeah.
So do you have 3 roadmaps going at the same time? 4 or 5? How many?
Pretty much. So when it takes between 5 and 6 years to do the processor work, 5 to 6 years, that includes the processor work for the full system development. But I introduce them every 3 years. So yeah, I'm always working on 3 of these at any given time in different parts of their cycle, which, sometimes can feel like chaos, but I kind of enjoy it. So, you're always in one phase of early concept and another phase of like almost time to ship. So right now we just launched Z17, but we are in the thick of it for Z Next, and a good chunk of us are working on Z Next plus one. And the only way we could really do that is, really understanding our clients, what they need, like having a clear sense of like how we're going to build.
How do you do that though when the market changes so fast? I
It's
mean, like
hard.
you mentioned, if something comes in and you go, oh, we got to have that. Are there ways to circumvent like some of the process to get leap in front, or are you just like you're screwed, or what?
This is where being a full stack offering comes into play. So my ability to really drastically change what's on the processor, diminishes quickly, a year or two out, maybe even 3 years out from announce and availability. My ability to change the firmware, which can maybe redirect some hardware, the operating system, the software is not limited. So we leverage our full stackness when things like that happen. One of the and the other way is we try to not get, ooh, look, shiny new thing, right? Like really staying true to our customers and what are their use cases in this enterprise space that we're serving, right? Like not every new trend is something we need to put on the mainframe. So really, it's hard. We're engineers. We want to build cool new stuff. So really thinking about like what serves our clients, and we'll ask them if we could do this or this, what would you like us to do? We can't do all the things we want. So we're going to make a call. We want your input. So it
Are
is.
clients always the best? This will sound like a weird question, but I'm channeling my inner Steve Jobs here. Do they always tell you what you need to hear? Meaning, clients will tell you what they want, but like what was the Steve Jobs quote? It was like, I'll tell my clients essentially what they're going to see or something. I don't know.
So we leverage what's called, like, we call it 3 in a box, 4 in a box. So clients are one input of that. My product management team doing all of the market work and understanding competitive data, trend data. Obviously our engineers in terms of like what's realistic to build when, sometimes I come up with something and they're like, that's not possible at all, Tina, in the next, whatever. And then we'll also take input from, our client support teams. So, our sellers in the field, what are they seeing and hearing? And, we try to come at it a different way, because you're right. Clients will always tell me what they want. And I have to sort of read through that a little bit. Like, so we'll ask them, and, we won't ask them like, do you want this widget? We really talk about what outcome do you want? What do you want to be able to say? What do you want to be able to do? And then let me worry about what widget I'm going to build and not get hung up on that. So we talk a lot about
that. Was actually, sorry to interrupt, but that was the quote. Steve Jobs said, it's not the customer's job to know what they want.
Interesting.
I mean, look, we value our customers at IBM like no one else. And I think that's the way it should be. But sometimes, they may not see what they really want because they can only see what they're addressing today, if that makes sense.
Yeah. And we have to, when we introduced quantum safe encryption, I think we had a lot of clients saying like, are you sure we need that now? And we were like, no, we need that now. Like everybody needs to get started now. And so a little bit is sort
example.
of, saying like, we know the puck is going there. We're going to get you ready to go there. And we know you're going to see it too, because they're facing a lot of the challenges we are, like day-to-day pressure, quarter pressure, or, the volatility in the market as things happen around the world. It's our job to help them see what could be coming 5 to 10 years from now, how we want to make them ready for a couple of things we see that could be coming. And that's why we spend a lot of time with them to understand, really how their workloads are behaving today.
But quantum's a great example in terms of quantum safe. I mean, it's not exactly sexy.
No,
and there's still some clients out there that are like, well, I got a little time. I mean, you have no time. I mean, you got to get quantum safe right now for critical information, because as we talked about, they're still in that data now. I firmly believe we're going to have like a DeepSeek moment. Remember when DeepSeek came out, and then everybody's like, "Oh man!" It's like, okay, we're going to wake up one day and it's going to be like encryption's broken, but we're ready, and we've been ready. But that's a case of getting out in front of it and saying, "I know you don't think you need it right now, but
we really with Quantum Safe, we didn't just introduce the technology. We said we're going to introduce the technology. We're going to give you the tools to find, do an inventory, like create a programmatic, methodical way to go through and replace the algorithms in a priority order. Like we did all of this to say, like, please get started, because we know. And even prior, just from working with clients, we know algorithm shifts are heavy lifting. So we knew this was a tricky space anyway. But I think that's a good example of us saying, like, no, you need it. We're gonna do it, and you should get going.
Speaking of it related, how do you balance modernizing mainframes and being state of the art the way you are? And by the way, you guys, anybody listening can go out there, go on YouTube and go the latest, look up the latest mainframe. I promise you're going to be amazed. The question is how do you balance being state of the art while maintaining mission critical workloads that simply can't go down? So I know that there's a lot of clients out there, back to our client conversation, rightly so, that are like, just don't mess anything up. This runs the most critical systems in the world. It cannot go down. And you're trying to balance, 8 nines at this point in time. So how do you do that and still be as innovative as you can be?
So I think if you go back to the question you asked me about how is it different to be a product manager in the mainframe space, when we talk about, software updates or firmware updates, I mean, they can't be disruptive. There's no your app stops working until you get the latest one from the App Store. I mean, we have to build that into our products, and we have to be really mindful of like these life cycle dynamics, non-disruptive upgrades. Our clients get, a scant 1 or 2 maintenance windows a year, right? So we build all of that into our thinking. We have the ability to basically do a push-pull of the system, and you never know it you would never know that from the application level. So that's one of the ways we have to, really think through. Even at the software level, there's a lot less tolerance for, needing a whole new version versus, smaller update. They treat their test environments like production level environments. So that we really do have to think through. We often spend a lot of time asking our clients deployment paths. How could you deploy this? What would be an obstacle? So to make sure that we don't ever have any outages that are unforeseen. And we also make sure we connect with our storage friends. So our friends in DSAK that, they're operating in the same way, are all of sort of like the periphery, because that's really they really just see it as like the mainframe environment. But it does add another layer of engineering riddles to solve when, you can't just say like, oh, just, put on a new version and off you go. It's not quite so simple for our clients, especially at the operating system level. I think that's where we hear it the most, upgrading an operating system.
I'm sure. Hey, I'm also curious, how does regulation shape your product decisions?
So that's, I would say the last 5 years has added to sort of this like volatility around the world. So the regulations are definitely driving mainframe activity. One of the hard things is keeping up with each of the regulations in the different geos, right? So you have EMEA that's doing things like DORA. They sometimes lead the way in a very stringent requirement way. You have data sovereignty regulations now are popping up in different geos, but they all have a little twist of their version of data sovereignty and what can and can't go out of country. So that we really rely on, our clients to understand timelines, connecting to the regulatory bodies themselves. You have industry regulations, card payment regulations, geo regulations. So all of that is a good way our clients are prepared because they do have the mainframe and what we can provide. But, sometimes we line up some timetables to try and figure out what we need to develop when, so that all of the certifications and things get in place. The other things our clients struggle with is just staying compliant. So it's one thing to have the technology. It's another to demonstrate that you're compliant to the regulation. And so we've amped up our offerings in the compliance space in terms of like demonstrating compliance and making sure that we can get system generated timestamp data. We're not, our clients don't have to have a spreadsheet and all these man hours. So that's sort of the other side of it, is proving you're compliant and meeting the regulations is really a headache for our clients that we've been trying to help them with.
Look, if you look 10 to 15 years ahead, given you're already planning well ahead, what's your bold prediction?
My bold prediction is we are going to figure out quantum compute with Z compute faster than we think. that's what I'm excited for.
Well, then I got to ask you my favorite question. Everybody who listens to the podcast probably knows, and you should be prepared for it if you actually listen to the podcast, which is what's true and nobody agrees with you on. What do you know that's true around mainframes? However you want to take it. That nobody agrees with
you. Well, I think what's true is mainframe has another 30, 40 years in it. I think we're going to see mainframe 100.
Mainframe 100. All right. I believe you're right, though. So it's at least me and you in terms of that prediction.
That's good company.
Is there any misconception, maybe the strangest misconception you've ever heard about mainframes?
Well, I mean, we have some like held over beliefs, like, the mainframe in 1960 that, it doesn't look like that anymore. It literally is smaller than some.
It's different. Yeah, it'd be like us saying, that's my point on the car thing. It'd be like us saying a Tesla is a Ford Model T.
Yeah.
Come on.
So you run into people and you're like, no, it's not like that at all.
Yeah.
So those are some weird, some weird things you hear. But I don't know, maybe I'm so immune. I hear so many wild things, but sometimes we surprise people with the amount of languages, the open source you can run on the platform in a good way. We are like, oh yeah, we've had Linux on the platform since 1999. I mean, like, we're all in, right? So, but every once in a while someone will be like, it takes up a whole room and you're like, not unless you buy a lot. Like, that's no.
Yeah, which we like if you want to do that.
Which I love. Yeah.
Yeah, totally. You mentioned Porsche earlier. If mainframes were a car, what kind of car would they be?
We have IBM sponsors Ferrari. I see a lot of parallels.
You better go Ferrari. Yes, you better go Ferrari.
I see a lot of parallels in speed, scale, performance, quality. I see a lot of parallels there.
All right, 2 personal questions. If we got that, the first one is look, if you could go back and give your younger self one piece of a career advice, what would it be?
Just try it. I mean, I think I spent a few too many years at the beginning, afraid to try something that I'm a classic middle child overachiever. And I think when I first got to IBM,
I got one of those.
I think I was afraid a couple of times to do something that I thought might make me look like I wasn't all that. And now I know that that's like a whole different kind of muscle. That like once I started doing that, like everything became more fun. So I think I would tell my earlier self, just try it anyway.
That's totally great advice. I mean, the other thing I was thinking about the other day is we spend so much time trying to make things perfect. I mean, not just career, just in personal life and everything else like that. And you realize that it's all the stuff that doesn't go well, the imperfections you remember. You forget all the perfect stuff because it went well. It's the stuff that went wrong that you laugh about today, you joke about, you tease your friends about. That's the journey and the fun because you had to learn from it. It probably wasn't pleasant always at the time.
And I would say
it.
The best relationships I have at work and probably in life are, when you go through something with someone good, you go through it with them and they're like your person. So I just had my 25th service anniversary lunch and
congrats.
Invited a core group of people. And for every person that joined me, I sort of said, like, here's the lesson I learned from you. And there was one woman and I said, Kelly has taught me that you don't need an army of people. Sometimes you just need like one person who's dedicated to the mission and you can do more with that than an army of people who are, not bought in.
That's awesome. All right, last question, and then we'll wrap up. What do you do for fun?
Well, I'm a mom, so I spend a lot of time momming. I was born to be a sports parent. I played athletics all through college, so I am happiest watching my kids do something, play soccer. My daughters
Now, are you one of those moms that are yelling on the sidelines, though?
I'm in a nice way. I'm not a
in a nice way?
So I played college athletics, and before I had my kids, I coached a local high school field hockey team, and those parents drove me nuts. So I would never be one of those. I clap when the other goalie makes a great save. Like, I appreciate good athletics. So I'm happiest watching my kids compete. And my daughter's a rower. She's rowing in college now, and I started rowing a couple years ago. So when I really actually do have some spare time, I've started to row. But I don't sit still really. So I like to row. I like to just keep busy.
Same. My body's beat up because I can't sit still either. But what sports you play in college?
Field hockey.
Field hockey.
Yeah.
Nice. Where at?
The University of Albany. I'm a Great Dane.
Oh, awesome. Yeah. That's fantastic. Well, thank you so much for sharing your insight with us. Where can folks reach you again?
I am on LinkedIn, Tina T. I'm at LinkedIn, and always happy to chat on the mainframe or anything else, really. It's hard to ask me something I won't answer. So I really enjoyed this. Thank you so much for
this is awesome.
Let me join.
Appreciate it. Anybody can find the mainframe out there, but I will put it in the show notes. Thank you for being here so much, Tina. Great to meet you in a podcast setting. Thank you all for listening. Hit us on almartintalksdata@gmail.com. We love that you're here. Talk to you next time. Bye-bye.